All right, here we are with the last lesson of the year, Unit 10, Lesson 4. We're going to talk about what is called the summation notation and the geometric series. Okay, so our objectives are going to be write and evaluate summation notation and use the formula to evaluate geometric series. Okay, so let's first take a look at what is a summation notation. Okay, it's going to be this thing that looks like this. Okay, and in the symbol there are three things. Okay, the top is the upper limit, the middle is going to be your rule or your formula, and the bottom is what we call the index. Okay, so summation notation is a way to write the sum of values in a series. So it's just a different way of writing, I want to add up all these terms. Okay, so for example, here I want to add up these terms: 2, 5, 8, 11, 14. Add them up. We've done this before, right? We add up these terms. So the summation notation is just a different way of writing this. So instead of writing 2 plus 5 plus 8 plus 11 plus 14, let's write it with this summation notation. So the first thing you got to do is you got to come up with the rules, or the formula for this sequence, right? So I'm going to write down the terms of the sequence: 2, 5, 8, 11, 14. Okay, and then just like what we did before, we got to figure out now, is this arithmetic or is it geometric, right? Is it multiplied by something to get to the next term, or is it adding to get to the next term? It looks like we're adding by 3 each time. Okay, so D is 3. The common difference is 3. So from that, you come up with the rule, right? Depending on which way you like to do it, 3 is a so 3n minus the 0 term, which is 1, or the first term, 2 plus 3 times n minus 1. So whichever one works for you is fine, right? Both of these rules will work. Okay, I'm just going to take the first one. It looks nicer, 3n minus 1. And that goes in the middle where the rule is. Okay, the index tells you, oh, n goes from where? Okay, n is the number of terms. So where do you start adding? I start adding at term number 1. So n has to equal to 1. Okay, because 2 is my first term. That's term number 1. N is 1. And then where do you stop? I count. If 2 is 1, and then 5 is 2, and then 3, 4, 5. 14 is the fifth term, so that's my upper limit. Upper limit is 5. And that's how we write in summation notation. Okay, example number 2, let's do that again. I'm going to add up these terms: 3 plus 6 plus 18 plus 54. Okay, you got to come up with the formula for the sequence. So what are the terms? 3, 6, 18, 54. What's happening between them? Am I adding the same thing over and over? No, I'm multiplying by 3 each time. Right? Multiply by 3. It's a geometric sequence. So my formula, my rule is 3 to the n, right? Or you could write it in the other way: 3 times 3 to the n minus 1, something like that. But not important. They're both the same. The rule is, in this case, I'm going to use 3 to the n. Okay, so I put the rule in the middle. And then I start again at the first term. So n equals 1. By the way, guys, instead of n, they can use I. They can use J. They can use K. Like a bunch of different letters that they can use for this indices. Okay, so index, they can use a bunch of different letters, not just n. Okay, but we're going to use n or I. They're most common. Okay. Anyway, so n equals 1. That's my first term. Where do I stop? The fourth term. So I put 4 on top. And that's how I write in summation notation. So now that you understand the summation notation, we're going to go and use that and go backwards and evaluate. Okay, so evaluate the summation notation. Here it is. They give you the summation notation. Again, the middle one, this one is the formula. This is f of n right here. 2n minus 7 starts at 1. Oh, that should be n. Sorry. So I, they could use I or n, but it's got to match, basically. Okay, this is a mistake. It should be 2i minus 7 or n equals 1 here. But let's just ignore that and move on. because I don't want to start over. So the way you evaluate this, they want to add up the first term, the second term, the third term, and the fourth term together. So I have to evaluate them, right? I find out when n is 1, what is it? I figured out, 2 times 1 minus 7. Okay, that's n equals 1. And then I got to do n equals 2. I put 2 in for n, and I solve, I get negative 3. And then I got to find the third term. I put 3 in for n, and I get negative 1. I put in the fourth term, so I put 4 in for n, and I get 1. Okay, so with these four terms, the first four terms, I have them evaluated. This summation notation means to add them, though. So I got to add all those four terms up. Okay, I add negative 5, negative 3, negative 1, and 1, I get negative 8. Okay, one more. Here, there's no mistake. You see, I matches with I, so there's no mistake here. So they want me to add again the first four terms, 1 through 4. So I got to evaluate when oh man, there's a mistake here. Anyways, this should be I. Whatever. You guys know what I mean. The variable is the same. And I should be I here. Okay. I equals 1. I'm going to get, you put 1 in for I. 1 minus 1 is 0. 2 to the 0 power is 1. 4 times 1 is 4. Okay. N equals 2, or I equals 2. I get 8. I equals 3. I get 16. I equals 4. I get 32. And then the summation notation, again, is called summation because you're looking for the sum. So you add them all up. So I get 2 plus 8 plus 16 plus 32, and I get 60. Okay? Now, if they want you to add something like that, like a geometric series, and there's like tons of terms, there's a formula that can help you do that faster. Okay? So imagine you have a geometric series. Now, this only works for geometric series, okay? Not for arithmetic. So geometric series, one more time, is of this form, right? You have I starting at 1 goes to some number, right? So you added the first n terms from 1 to n. And geometric series, the formula has to have a number in front, and then we call that a, or the first term, okay? And r is the number that is being raised to some power, and that power is in accordance to the I. Okay, so I know that sounds all abstract and weird, but once you see the example, it'll be easier. Okay, so anyway, what that means is you just have to add a. Right? The series looks like this: a plus a times r. Right, that's the second term, plus a times r squared plus a times r cubed, blah blah blah, all the way to a times r to the n. Okay, if that is what they're looking for, we can use this formula. Okay, the formula is a times the quantity of 1 minus r to the n over 1 minus r. Okay, you should copy this down in your sheet. This formula is going to be, you don't want to memorize this formula, right? You just want to have it to look at when you need to use it. Okay, so let's use that and do an example. I want to leave that formula in the corner of my page so I can go back and look at it. It's right there. Okay, so here's an example. See, they want me to add from the first term to the 11th term. And this is a geometric series because there's a number in front. That's my first term. 4 is the first term. And then r is the ratio. 3 is the ratio, right? Because I keep on multiplying by 3 a bunch of times. So 3 is the ratio. Okay, so to use that formula, I need a, I need r, and I need n. Let's look into here. Okay, what is a? A is the first number, 4. What is r? R is the ratio, which is 3. And n is how far you're going in terms of the terms of the series. Okay, so I go up to the 11th term, n is 11. I'm going to put that into my formula. I get 4. Okay, 4 is a. 1 minus r, r is 3, raised to 11. That's n. Okay, over 1 minus 3, 1 minus r. Okay, and you solve that out, I get 1 minus, 3 to the 11th power is some weird huge number like 7 million, right? Okay, but the calculator can do that for you, no problem. Okay, and then you put all that into the calculator, you get 354,292. And you see how it's a huge number? If we did it by hand, it's going to be a lot, right? It's going to be really hard to do this by hand. That's why we have the formula, okay? Now, let's just make sure that it works. My next example I have for you is going to be the one that we did earlier, the same problem we did earlier. It's just going to go from the first term to the fourth term. We did this by hand earlier. Let's see if the formula works, right? Okay, so let's figure out our A, R, and N, right? A, first term. R is the number that's being raised. That's 2, and N is 4. Okay, put that into the formula. I have 4 times 1 minus 2 to the 4th over 1 minus 2. You simplify all that, you can do this in your head, really, right? 1 minus 2 is negative 1. 1 minus 16 is negative 15. Negative 15 over negative 1 is 15. 4 times 15 is 60. It matches the example earlier, number 4, that we did. Okay, so this formula works, and it's helpful when you have a really long series.